Hello everyone, welcome back to my YouTube channel. This is Sahana LK from 4th Sem Tejas section from the Department of Electronics and Communication. Today I am here to present the subject of microcontroller. In that I chosen a topic of 8051 C program to generate a rectangular wave of 2 kHz with 60% duty cycle in p1.2. Assume crystal frequency as 11.0592 mHz. Use timer frequency in mod 1 operation. Show delay calculation. Let us discuss. Introduction is here. The 8051 microcontroller is widely used in embedded system for its simplicity and versatility. Generating a rectangular wave of a specific frequency and duty cycle, it is a common requirement in various applications, and in this presentation we will discuss how to generate a 2 kHz rectangular wave with a 60% of duty cycle in the 805 microcontroller by using this 8051 microcontroller. Let us discuss some points about the crystal oscillators. The 8051 microcontroller relies on a crystal oscillators for accurate timing and frequency generation. A crystal oscillator provides a stable clock signal that is crucial for precise operations. In our case, we will assume a crystal with a frequency of 11.0592 mHz for our 8051 microcontroller. Let us go through the calculation to calculate the timer value. To generate a 2 kHz rectangular wave, we need to calculate the timer value for the 8051. The formula to calculate the timer value is timer value equals to crystal frequency by 2, which is having a required frequency minus 1. As here given some given data as per the question. Here we having a crystal frequency value is 11.0592 mHz, which is the input of clock is also same value. X times of 106 equals to same the value in terms of millihertz. After that, here we having a formula in that the data T in equals to 1.085 microseconds. After the assuming and otherwise we are giving some values, after that we will get these values for the 2 kilohertz square waves. The frequency output will be the 2 kilohertz and timer out will be the 1 by 2 of x times of 103 and T out will be the 500 microseconds. In order to consider the half of it is nothing but T out seconds, we will get the 250 microseconds. Next, n equals to T out by T in, where T out is the 250 microseconds and T in is the 1.085. After that we will get this much answer. In order to calculate the given data in terms, we should convert into the hexadecimal. Here we having the number in decimal. After that converting the decimal to hexadecimal, we will get the final answer FF1A. Next, this setting the duty cycle. The duty cycle is the ratio of time the signal is high to the total time period. For a 60% of duty cycle, the signal is high for 60% of the total time period. We will adjust the timer values to achieve the desired duty cycle of 60%. Here, we should write the C program based on the given data. What we have calculated here, this hash include register 51.h. This is what the program. Here T mode and Tcon are the specific register. They are not the types of the timers. Timer 1 and timer 0 are the types of the timers. This is what we are giving the inputs 0x01. This is the set timer 0 in mode 1. That is the 16-bit numbers. Here TL0 equals to 0x1AH. This means to load the TL register with LSB of count. This is TL is nothing but the timer lower, TH is nothing but the timer higher. This is also we given some inputs. This will tell us how to load the TH register with MSB of count. Most significant bit and least significant bit, which is represent LSB and the MSB. Next, we will go through the initializing the timer register. To generate the desired frequency, we need to initialize the timer registers in 8051 microcontroller. We will load the calculated timer value into the timer register to set the time period. The timer will overflow at the specified value, generating the rectangular wave. Configuring the output pin. Pin 1.2 will be configured as an output pin to derive the rectangular wave. Setting the pin as an output allows us to toggle the signal high and low generate the wave. We will use the appropriate register to control the output of the pin 1.2. The implementing the duty cycle. Here we will discuss how to implement the duty cycle. To achieve the 60% duty cycle, we will adjust the high and low times of signal. By controlling the timing of the signal transition, we can ensure the duty cycle meets the requirements. The program will continuously generate the rectangular wave with a specified duty cycle. At last, we will go through the conclusion. Generating a rectangular wave with a specific frequency and duty cycle is achievable with the help of 8051 microcontroller. By writing the C program what we have discussed and configuring the timer and output pins, we can generate the precise waveforms. Understanding the fundamentals of timing and frequency calculation is essential for the accurate waveform generating in embedded system. Thank you.